What we're going to do now is we're going to be solving exponential equations. We're going to look at two different ways. One we've already talked about, and that's finding a common base. So what we're going to do is we're going to review that method of looking for a common base. Now, with our first one, we see a 2 and a 64, and we know that they have a common base of 2. So we have 2 to the x equal to 2 to the 6. Since both of them have a base of 2, we cancel, and our answer is x equals 6. Now, if we're looking at the second one, in the same way, what we're doing is we're looking for a common base. 3 and 9 both have a base of 3. So we have 3 to the x equals 3 squared. That gives us 9. And then we have our x minus 1. Once again, we have a common base, so they cancel. And when we're looking at that, that gives us x is equal to 2x minus 2. We're going to subtract the 2x on both sides, and that gives us negative x equals negative 2. That means that x is equal to 2. Looking at letter C, what we're going to do is we're going to do the same thing. We're going to look for a common base. Our common base in this case is going to be 2. So we have 2 squared, that's 4. And what we have is 2 to the negative 5. The reason that it's 5 is because 2 to the 5 is 32. The reason that it's negative is because the 32 is in the denominator. So once again, we have a common base. We cancel the common base. That right there gives us 2x plus 6 is equal to negative 5. We're going to subtract the 6, so we get 2x is equal to negative 11. And when we divide it by 2, we get x is equal to negative 11 halves. So that right there gives us our answer. Now, that brings us to the other way that we're going to solve exponential equations. And that right there is using logs. The reason that we're going to use logs is because in each of these examples, we're not going to have a common base. Now, when we're solving these, the first thing that we have to do is we have to isolate the base number. The base number is the number underneath the exponent. So this right here, 3 is our base number. That means in order to isolate it, we're going to divide by 2 on both sides. When we divide by 2 on both sides, 2 cancels, the 12 becomes a 6. 3 and 6 don't have the same base. So that means we have to do a log of base 3 because our goal is to get rid of the 3. And we know that when we have bases that are the same, it becomes 1, so we're left with our exponents. For log base 3 of 6, we're going to use change of base formula. We're going to take our log number, put it on top. We're going to take our base number. We're going to put it on the bottom. Then our last step, we isolate the variable. So we're going to subtract 1 in order to get our answer. Now, when we're looking at example 2, first step is to isolate the base number. So in order to do that, what we're going to do is we're going to subtract the 3. So we get 2 to the x is equal to 6. Now what we need to do is we need to get rid of the 2. So what we're going to do is we're going to do the log base 2. And the reason that we're going to do the log base 2 is because whenever we have base numbers that are the same, it becomes 1. We take our exponent and we bring it to the front. X times 1 is x. Then we're going to use the change of base formula. Log of 6 divided by log of 2. And we're going to put in our calculator. Log of 6 divided by log of 2 gives us 2.58. Now, looking at letter B, we're going to do the same thing. What we're going to do is we're going to get the base number by itself. Our base number is the 2/3. That means we're going to subtract the 8. So we have negative 2/3 is equal to negative 7. We see that both of them are negative, so we divide it by negative 1 or multiply it by negative 1. Then what we're going to do is we're going to find the log of the base number. The base number is 2/3, so we're going to do the log of 2/3. Since the base numbers are the same, they become 1. We get the x by itself. Now on the other side, we have to do the same thing. We're doing the log of 2/3 of 7. Change of base tells us that would be log of 7 divided by log of 2/3. When we take the log of 7 divided by the log of 2/3, it gives us an answer of negative 4.80. Now, looking at our last example, we're going to do the same thing. We're first going to add the 6. So we get 7 times 5 to the x plus 3 is equal to 89. We're going to divide each side by 7. Now, when we divide it by 7, the 7 doesn't go in evenly. So we have 5 to the x plus 3 equals 89 over 7. Now we need to get rid of the base 5. So what we're going to do is we're going to do log of base 5. So log of base 5, log of base 5. This becomes 1, so we get the exponent by itself, which is x plus 3. With change of base formula, what we're going to do is we're going to rewrite it as log of 89 divided by 7 over log of 5. Which that right there gives us an answer of 1.58. Now, because there's an x plus 3, we're going to subtract 3 on both sides. And when we subtract 3 on both sides, we get our final answer, which is x is equal to negative 1.58.